Hi everyone, and welcome back to the Kahal Narrowkit course on visual reactive programming. Today we'll be discussing the core operations of reactive programming that you use when you are building up a Bonsai workflow. We'll start by doing a short recap of yesterday's discussion of observable sequences, and then move on to go through the marble diagrams for each of these basic operations one by one with examples. So yesterday we discussed the concept of an observable sequence, which is the fundamental element of reactive programming. Sometimes we use a metaphor to make this concept of an observable sequence easier to understand, and I wanted to share that with you. So that metaphor is Twitter, and if you think about Twitter, at its essence, there's really only two things you can do with the Twitter account. One is you can make a post reporting your status at any point. Those posts will be ordered in time. And the other thing you can do that is fundamental is you can follow other accounts on Twitter. And once you follow other accounts, what will happen is you will get notifications of when those accounts have posted some new tweets themselves, which you can then respond to. And that is basically the same idea that you can think of in terms of Bonsai observable sequences and reactive programming observable sequences. Imagine, for example, now that instead of having a Twitter account owned by a human, if your webcam could have a Twitter account, then you could imagine that the webcam would post a new tweet every time that a new frame is grabbed, continuously as it grabs new frames. And if you now imagine that the Twitter account existed and that you could follow it, then you'll be notified for every snapshot that the camera is taking. Also adapted to think about the Bonsai workflow itself as being a social network where each node is an account, a Twitter account that makes its own tweets, its own posts. And then the connections represent the follow action. So in this case, you can imagine that the camera capture has the Twitter account we were just discussing, and Grayscale has its own Twitter account, but it follows the camera. And so yesterday we also discussed marble diagrams, which are essentially the dynamic picture of a workflow, a Bonsai workflow. And in the marble diagrams, it's essentially a representation in time of the dynamics of a workflow. We also saw a little bit more complicated example of sample that now receives notifications from two sequences, and sample receives those two sequences of notifications and essentially returns the latest frame coming from the Grayscale only when keydown produces a value or makes a tweet. And you end up with another sequence of notifications that you can then continue to transform. Yeah, so this is the general pattern for syncs. So in general, one example we didn't cover, but we will now because it often comes up, is the concept of a condition. So the idea here is that whenever we press a key, we might want to have sample not respond to any key press, but only to a specific key. So we can decide, we can have more control over when to actually take a picture. And the way a condition is represented in a marble diagram is like this. So you can imagine that a key down can have different values depending on which key is pressed, and condition is only looking for specific value of the key, and only those values are emitted, retweeted, if you will, into the result sequence. In the final part of this lecture, we will go through a number of operators one by one, look at their marble diagrams, look at some examples, and with the goal of getting a good feel of how to read marble diagrams, how to understand bonsai workflows, and in general, getting to know these operators that will put you in a much better shape to know how to write your own programs and become independent user of Bonsai. Okay, so the first one we'll look at is very simple. It's called skip. So skip, what it does is it takes a number as a parameter, in this case, skip 2, and it receives a sequence as an input. And what it will do is it will drop the first 2 elements from the input sequence. So you see here, these first 2 elements were not appearing in the second sequence, in the result sequence, and then everything from there on, from the third to the last, it's replayed as normal. So no changes after the first n elements you specify here. So why would this be useful? You could imagine, for example, a common use case. I mean, there's many use cases actually, but a common practical one where skip can be used just by itself is if you have a camera, a webcam. Sometimes they have an auto exposure feature where they will adapt the amount of light, the amount of exposure that the camera is doing to the amount of light in the room. And sometimes if you're taking a background of the image or doing some kind of operation that depends on a fixed exposure, you have no control over that auto exposure, but your lights are stable in the room. So one solution is to basically ignore those first few frames where the camera is adjusting the exposure. So, and you can do that with skip, so that when the video feed actually starts, you start with a clean feed with no changes, overall changes to the lighting. Okay, the next one we'll look at is take. And take, what it does is the complement of skip. So it also takes a number, in this case, take 4. And what it does is it takes, as the name implies, it takes only the first n elements in the sequence. In this case, it takes the original sequence was this one with 6 elements in a complete, and now it starts to react to the elements. So it gets the first one, the second one, the third one, the fourth one, and after receiving the fourth one, without waiting for another element to arrive, it just terminates the sequence. So it just says that the sequence has terminated successfully and cancels the subscription to the original sequence, to the source sequence. So this makes take very special in the sense that it really modifies the original sequence, truncates it, and it's particularly important when you think of sequences that are potentially infinite, like a camera, for example. A camera never really ends its sequence; it just takes frame after frame until you basically stop the workflow in general. But if you insert a take after the camera, then you can actually make it stop. Now, these operators, both skip and take, have dynamic variants, and this is also something that you will notice is quite common in the reactive toolkit. And basically, what they allow you to do is be a bit more flexible in how you specify when to skip it and when to stop taking. So the skip until operator is the dynamic variant of skip, as I was saying. So you start with a sequence. And now, instead of saying a specific number of elements to skip, what is going to happen is we are going to provide a second sequence that will tell skip until when exactly to stop skipping. So in this case, basically, you can see the marble diagram that elements are arriving, and they're all being ignored until the second sequence sends a notification, and then after that, skip until starts emitting all the values from the original sequence. Now, the complement, you can imagine what it's doing. So it take until does exactly the same thing, but now instead of specifying a number, you get a notification to tell you when to stop taking elements from the sequence. This one is particularly interesting because it allows it to dynamically stop. So one important thing to realize from these operators right now is that they are not tied to any particular device or data type. So they work the same whether you're using a camera or a microphone or an eFIS acquisition system, or a sequence of button presses or poke clicks or whatever it is you have as a sequence. Take until will stop that sequence. Skip until will ignore elements from that sequence, and they don't care about the type of the data or where the data comes from. The only thing that matters is they have a sequence that they can control, that they can subscribe to, and they can cancel the subscription to, and they take elements from that sequence. So this is really nice because it really helps separate this problem of control that can be very complicated in traditional programming languages to address, and it just makes it very separate and very simple to express in a way that is useful anytime we need to do something like this. Okay, so another interesting operator is delay. So delay now does something a little bit different to the elements of a sequence. So it starts by subscribing to the source sequence. So you specify some delta t value, and then it basically receives those elements as they come in, but it applies a fixed delay that you specify to each element, so that the source sequence is actually shifted in time by the time interval you specified here. But otherwise, all the elements arrive in their order, in the same order, in the same timing, but just everything is shifted, including the termination event. So for example, if we go back and we try to write this example very quickly, you just put a delay here, delay reactive. And you'll see here, we can put it at due time. So let's put a second of delay, or maybe 3 seconds of delay. Okay. And now if we start the workflow, we can compare the two streams, and we can see that the second stream is delayed 3 seconds from the first. But otherwise, they seem to be going at exactly the same rate. There is an interesting variant of delay called delay subscription that implements also a shift in the result sequence, but does it in a very different way. So what delay subscription does is wait either for a given time, or there's also a dynamic variant called subscribe when, which is what's actually represented here. That it waits for an event, which could be a timer, but it could also be something else. And it only subscribes. So instead of subscribing to the sequence right from the beginning and then delaying the items that come in, delay subscription or subscribe when will just shift the moment of subscription. But from that moment on, everything is immediately propagated to the result without any time delays. So you can compare the two marble diagrams. So here in delay, subscription is immediate, but the elements are shifted, whereas here the subscription moment is shifted, but each time we get a value, we immediately propagate it to the result sequence. So now you can imagine the difference between these two operators when looking at our camera example. If we now replace this by a delay subscription, you can do by doing replace here. What you'll see now is that essentially we need to specify here time. So now what we see is that there's nothing for 3 seconds, and then the sequence starts. So the subscription has been delayed by 3 seconds, but now there's no difference between camera capture and delay subscription. So basically, the only effect of the delay subscription was to postpone the start of the sequence. This difference is important because we now understand that there are effects that are happening in the moment of subscribe and cancellation. So when we either start following a sequence, we can start hardware running, and when we stop a sequence, we can cause hardware to shut down. So having control over both moments can be very important. And we can now put everything together by looking at one final operator called repeat. So repeat is also something that we tend to use quite a lot, but it's interesting to understand the subtleties of it. So what repeat does is it takes a sequence that terminates. So repeat only works on finite sequences. If you give it an infinite sequence, there will be no effect because repeat, there's nothing to repeat. But if the sequence does end with a successful termination, what repeat will do is it will then subscribe again to the source sequence. And if the source sequence is something like, for example, a video file or even a camera, it will start again producing values, and repeat will get those values again. And from the point of view of downstream observers of the sequence, this will all look as one single long continuous sequence. Let's put all the operators we've learned about together in an example, and I think we'll understand a lot about what is going on with Bonsai with that one example. So let's start with just using the skip and take variant, and to save a file that starts and stops in a certain with a certain moment we indicate. So I will start by using skip until with a key press as before. And after that, so now we will define a key, specific key to start the sequence. Let's say we press S to start the sequence. And now I will add another key down to stop it. That is T, stop the sequence. And now, so what we do is we skip frames from the camera until the S is pressed, and we take frames from the sequence that has a skipped frames until we press T, and we send all of that to a video writer. So video, so click.avi. And let's set, so remember one important thing before we go on with video writer, one effect. So the same way that the camera has an effect when there's a subscription to it, that the camera starts serving frames, there is also an effect of subscribing to video writer, which is a file needs to be opened to receive on which to dump to save the frames that arrive. So clip.avi does not exist, has to be created, and it is created on the moment of subscription when the video starts receiving frames to save to disk. So when we run this workflow, if we run it like this, the clip AVI would be created as soon as we start getting frames from the sequence. But what would happen is if we run it again, the same file would now exist, and for safety, by default, Bonsai would not let you overwrite the same file. You can set a flag to overwrite it, which you can use for tests, but otherwise, usually for data, you don't want to do it. The other thing that is useful that we discussed before in our save image example yesterday is you can have a suffix that basically appends to the file name the time. If you choose timestamp, it will append to the clip.avi to the name the time of day when we started saving the video. So now if we start the example, we will see that we have camera capture here. We have skip until is not started yet. Take until, of course, because of that, is also not started, and there's no data going into our video writer. So now we can follow the logic that we set up here. So I will press S to start the sequence. And you see now we're recording data into our video. And now I'll press T to stop it. And you see when I press T, the whole workflow stopped. And so why is that? So this sequence terminates. And because the sequence terminates, the video writer also terminates because it receives the notification event, the completion event from this sequence that ends. And because the sequence of frames is ended, then video writer has nothing else to do. It just needs to close the file and itself will end. So because all these sequences have ended, there's nothing else in the workflow to run, then the entire workflow stops because there's essentially nothing else to do. There's no repeat here. There's nothing that keeps this workflow going. So as soon as all the sequences in your workflow stop, the workflow will stop. One thing we would like to do now is to do multiple repetitions of this sequence, right? So that we can save multiple clips. Because now what we have to do is we'd have to start this manually and keep going every single time. How can you do this? The insight is to use repeat, right? That we just learned about, as you can imagine. So repeat, what will happen now? So I was just describing that as soon as you press T, the sequence take until ends. The video writer notices the sequence has ended, so closes the file. And repeat will simply resubscribe, restart the entire sequence. So we'll restart video writer, restart take until, skip until, and the camera itself. So the camera will start again, take pictures, and the same logic will run. So we'll wait until the S is pressed, and then take until the T is pressed, and the new video will be opened with timestamp and closed with when we press T, and then everything starts all over again. So I will now run this, and I'll position the camera slightly different so you can see what's going on. So the idea here is we will run the workflow, and see nothing's happening. Our old file is still in there. No file has been created yet until we press S. So we're going to press S, and I'm going to move a bit so you can see the keyboard, understand. So S is here, T. So when I press S, video starts being recorded. You see the video was created here. Now when I press T, okay, the video has stopped. Now the camera is already going because it started again, but the skip untils, take untils has stopped. The video is already recorded, but now I can start another clip again. So if I press S, another recording starts, a new clip is created, and everything is going exactly as we indicated until I press T again. I can just keep doing this and creating clips, where basically it's the moment between I press S to the moment I press T. Get clips that all contain just those moments. If I look at them, they all look the same. From S, they start after I press S. And then now, an interesting exercise we can try is to manipulate all these operators we've set up here. So so you can understand the subtleties of this subscription. So for example, what would happen if I were to move repeat, because we put repeat at the end here. One might wonder, but couldn't we just put it here, like before the video writer and just after take until? What would happen in this case? So now it gets a little interesting because the sequence would repeat. So the camera starts, skips, takes, and so on until we press S and T. And then the sequence completes here. Repeat will resubscribe to this sequence, and the camera will start over again. But now the interesting thing is that video writer is downstream from repeat. So as I was explaining before, from any operators downstream from repeat, they will just see a single sequence. They don't get to experience the effects of subscription. So actually what will end up happening here is that we will get a single clip with all the sub moments that we skip and take, that we select from with the keys here. So if I now run this again, you will see that nothing starts until skip and take. And now the video starts, a clip has been created. But now, you can see that what I'm doing is basically recording a series of clips, but only everything is going to a single file. So if I now stop the workflow and have a look at that file, it'll look very interesting, because basically it'll contain only clips of my hand moving from S to T. The first one was a bit longer one. It took me more time to do it. But the interesting thing to note here is that they all went to the same file, because Video Writer was downstream from repeat and not upstream. So if you put it here, the resubscribes will affect the Video Writer. If we put it downstream, then it doesn't. So that's something that is interesting to understand from this example, the effects of subscription. Now, one last modification we can do here, that is interesting to think about, is now we have two key presses, S and T, to start and stop the clip. But what if we wanted to have the same key to start and stop? Let's say spacebar will start and stop the clip. Now, one interesting thing about doing this like that, so we could just have a single key press. It goes both to skip until and to take until. Now, one problem with this, and the reason why this doesn't work, is that skip until is controlled by the spacebar, but also we have take until running at the same time. So what happens here is that when we press the spacebar here, we're effectively not just starting the sequence, but also simultaneously stopping it, because it triggers both skip until and take until. So this is an example of where the difference between skip until and subscribe when can be very important. Because skip until starts the whole sequence right away, but subscribe when will only subscribe to the sequence after the event arrives. So if we just, instead of skip until, if we use a subscribe when after the take until, this is important. So if we work with me to see what's going on, so subscribe when will basically this whole sequence here, camera capture and take, will not start until the first spacebar is pressed. So when I press spacebar, I will subscribe to the sequence. So that means that I cannot, at the moment I press the first time the spacebar, take until is not listening, because it's not been subscribed to yet. So after it gets the first spacebar, this branch is no longer active, and the sequence starts. And then when we press spacebar again, take until is triggered, and this branch is closed, everything is closed, then repeat gets notification that this has completed and repeats everything again. And we can move, I'm going to move this again here, so we get different clips for each time I press the key. So if we do this now again, you will see that whenever I press spacebar, a clip is started, and then when I stop the space bar, clip stops, press space bar again, new clip starts, space bar again, clip ends. So that's how we can do something like that. So hopefully these examples were useful to give you an insight of the importance of subscription and the different effects it can have in how you control things. Okay, so now we are moving to combinators that actually bring multiple sequences together, the data from multiple sequences together. And two of the most important ones we'll cover now. The first one is zip. And zip, what it does is it brings together the data from two sequences. So you can see the output of the zip is a tuple or a pair of the two elements together, paired together. And the question that the marble diagram tries to answer is, what is the pairing order? So what determines the timing of the outputs of zip, and what items go in each pair? So you can see from the marble diagram that essentially zip cares only about the order of the elements arriving in a sequence and doesn't care anything about timing. The way we can see it is that it takes the first element from the first sequence, the second element from the second sequence, and forms the first pair. Then when the second element, the orange circle, arrives, nothing exists to pair, nothing new exists yet to pair with zip. And even before anything arrives from the second sequence, a third element arrives from the source sequence, and again, nothing happens. And now when finally the second element from the second sequence arrives, that gets paired with the second element from the first sequence. So those two get paired. And then these two get paired. So essentially, you can see that even though more elements are arriving from the first sequence, zip still remembers the order of arrival. And that's the basis that it will use to make the pairs. And this is really important. You've probably seen it yesterday in the worksheet. When you played around with zip and combine latest, you noticed that this was going on. So this is important because it allows you to align certain events together that might have slight delays relative to each other, but if you know that they match one-to-one, that there's a match between the events on the first sequence and the events of the second sequence, then you can align them by order of arrival, irrespective of time. What you need to be careful of is that you don't that you know that it's the case that they match, that the order matches. Otherwise, you can start zip memorizes all the elements from either of the sequences. So if one sequence is, for example, much faster than the second sequence, then zip will start growing and growing and growing the memory that it needs to store the first sequence, because there's nothing coming in for the second sequence to unblock it. So it's really can be really useful, but you need to know that the two sequences match. Now, the kind of a complement in time of zip is combine latest, and combine latest does it does, as I was saying, the complement of zip is that in that it doesn't care so much about the order, but cares more about the timing of the elements arriving in combine latest. And you can see now that it's the same as zip. It makes pairs on the output sequence, but now the basis for making a pair is just proximity in time. So so if we look at the first element from the first sequence arrives, and at that moment there's no pair to be formed because nothing has yet arrived on the second sequence. But as soon as something arrives there, you have a pair as before. And now, as soon as another element arrives from the first sequence, we make the combine latest will make a new pair, because these two are now closest in time. And if now the first sequence emits a third item, it immediately gets paired again with the latest element from the second sequence, and then another pair is formed. And basically this continues. Now finally the second element arrives from the second sequence and it gets paired immediately with the latest from the first sequence, and it's always like that. So you get all these pairs which are the closest in time between the two sequences on the output. So this is interesting because it's doing a kind of temporal correlation or temporal alignment of the two data streams, that it's the closest in time that they arrive. You know that you will get those pairs, that they are always the pairs that are closest in time for each of the sequences. So you got to see examples of this yesterday with background subtraction and the frame by frame difference that took advantage of these properties to make these functions. And so hopefully now it's clear what these marble diagrams are doing. Another variant of combined latest, in a way, is called with latest from. So with latest from is basically like combined latest. It makes pairs, but now the idea is that only one of the sequences. So with combined latest, any of the sequences, as soon as it produced a new value, it got paired with the latest in time, with the closest in time from the other sequence. Now, with latest from, only one of the sequences is going to drive the production of values. In this case, the first sequence. So the first sequence, of course, when it gets an element, there's nothing to receive, so no pair is formed. Then you see the second sequence produces an element, so now there is something to pair, but nothing gets produced because the sequence is not the driver of the output. And now the first sequence again produces a value, and now it will take the latest. It'll pass that element with the latest from the second sequence, and that's, you get a pair. Then you get a pair again because this is the driver. And now the second another element arrives, the latest is updated, but nothing gets emitted until again the driver sends a new value, and then you get another pair. So this is basically the same as combined latest, but now with only one of the sequences being the driver. This can sometimes be useful, so you don't send in too much redundant information. If you know that you have one data stream that is much faster than the other ones, and you just want to take the latest value, in time, you can do it like this. Okay, so now we're approaching the final stretch of our lecture. If what I'm going to present next doesn't make sense completely by the time we go over it, but you'll have a lot of chances to see in the following days how to use these operators, how they work in detail, and it really helps if you revisit them several times and think about them in the context of what we've discussed so far. So don't worry, you'll have lots of chances to practice, but it's also good that we introduce them early, so that you are aware that they're available. So we start with a transform. So this is sometimes called a select operation because you're selecting an attribute or a transformation or a derived property of the items. You select from one circle, you select the diamond. From one circle, select the diamond, and so on. So the operator we'll discuss now is a generalization of this to multiple items. So it's called a select many. And the name comes from exactly what I was describing now. So now instead of selecting just from one or transforming from one element, you derive one output. You can now, from one element, derive multiple outputs. Now, the question is, how can this be? And the answer is, it can be whatever you want. So the way the select many works is now a little bit different, because with select many we need to specify an extra part of the operator, which is how we want to generate the items. And the interesting thing about select many is that it does that by Bonsai allows you to express what goes inside select many by writing workflow that defines how the observable sequence that is triggered by select many will operate. So what this means, just before we go how we define these sequences, what this means is that select many will merge or overlap all the results that are generated by the input events and we'll merge or flatten everything into one single sequence where you see all the results that were gathered by the operation that we specified is triggered by the select many. Okay, so that's something important to keep in mind. But let's look at a concrete example that I think will make this much easier to understand and more concrete. Okay, so to take a concrete problem to look at select many, let's imagine this. Let's say we wanted to play audio on a cube, and so you've done this yesterday. In one of the exercises, you had to record a WAV file and then play it back through the speakers using audio reader connected to audio playback. So that'll play, we'll open the file, all the samples will be read, it'll pipe them to the speaker, and then the workflow will end. And if you want to play the file again, you'll have to start the workflow again. And it does it as many times as you want to play, but it doesn't do it on a queue repeatedly. And you saw it yesterday, different ways of solving that problem. And now I want to show you one more way using select many that I think will make it very clear what is happening. So we can do it directly with select many. And the way to understand this is basically, this is the diagram. So we will have key down connected to select many. So that's the source of inputs to select many. And then the way select many works is it's a group node. So we can group workflow inside the operator. And what we will do is we will place exactly the workflow for playing a sound inside the select many. And that will basically get triggered by the key down. It'll start playing the sound to the speaker. Okay, so let's start by recording the audio clip that we will want to trigger with select many. So first we put an audio capture, and then an audio writer. It's the file name, and we record our sound. So now we have our clip here. And we can now place the audio reader pointing to that same file. And we pipe that to the audio playback. So now we have the sound playing as whenever we want by pressing start on the workflow. Now, what we want is not to have to press start on the workflow, but to trigger the sound playback by the key. So essentially, we now want to have a key down, a single key down. We want to select many events, many notifications, and our events, the things we want to run inside select many, are exactly the samples playing back through the speaker. So that's the sequence we want to run inside select many. So if we just cut the workflow we wrote here, so now select many, and this is the trick. How do we specify what is the sequence that gets generated from each key press? So the way we do it is we define it inside the select many. So select many is a group that you can open up. So if you double click, you will get a window that basically allows you to define a new workflow. So by default, it places the actual input that arrives to select many and sends that to the output. So no change will happen to the sequence. But in our case, we just want to paste the workflow we have here, and we actually don't want to send any output out, but select many will still have to play the sequence through to the end. So if we just delete this now, so that's what we have. We have a key down. For every key down, select all the samples, all this workflow playing through the speakers for every key press. So if I now start the workflow and we press a key, you hear that the sound has been played once. And if we now do it again, for every time that I press, I'll get a new play. Now, if you remember the playback, the behavior of select many, that it combines all the sequences that are running, that are triggered by the key press. You can imagine what happens if I press the key again before the sequence has started playing, right? So what will happen is two playbacks at a sound will start at the same time, and they will overlap in time with each other. So I will do that now. 1, 2. You see we got two clips playing at the same time, which is why we heard the two claps. So you can see it here. It's basically what's happening here. So when a key press arrives, the samples from the sound start playing, and if another key press, if we play, then if we're playing a sound from a key press, and in the middle another input arrives, another notification arrives, select many, then the workflow starts overlapped with the previous workflow, and those notifications will all happen in parallel. So that's a very important thing to understand about select many, because we will, it's a source of great power, of things you can do with select many, but also something you have to watch out for as you make more complex workflows with select many that we will do in the next lecture. Okay, so that'll be it for today. We covered quite a lot. We went through all the basic reactive operators. We saw quite a lot of variants of marble diagrams. There are plenty more operators that you can check in the help in Bonsai documentation, but the ones we covered here should give you quite a good solid basis for you to be able to read the diagrams for the operators we haven't covered and still understand what is happening. There's just one more type of operators that we will cover tomorrow, higher order operators that introduce one more twist in the marble diagram. That'll be the last one, and will allow us to do even more powerful things when it comes to talking about experimental control. But we will look at that tomorrow. So as always, any questions, feel free to head to Discord, add comments, and also bring them up during the recap sessions from 1 to 2. And we will answer all your questions, and the worksheets will be a great way to follow up on all this. Okay, so see you. Thank you again. See you tomorrow.